Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 17 of the condensed matter physics. Okay, so in which I am going to discuss Hall effect. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details to your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started guys. So Hall effect. Okay, Hall effect, I'm going to discuss Hall effect. It's very important. Usually you get the 5 marks or 3.5 marks question in CSIR net. Okay, so Hall effect. So Hall effect I'm going to explain. Okay, so I'll make a diagram for this. This is y-axis, this is z-axis, and this is x-axis guys. Okay, so this is the conductor. Okay, the thickness of this conductor is d. The length of this conductor, is L. Okay, length of this conductor is L. Okay, and this width is W. Okay, and yeah, this is the W. This is, and also guys, I current flows in the conductor, and along the x-axis direction, there is a magnetic field B is applied. Okay, so current I is flowing, and along minus this z direction, there is an electric field E. Okay, so so there is random motions of the free electrons in the conductor, right? And because of magnetic field, what happens is the electrons start moving downward. Okay, along the minus z direction, and due to that, what happens is uh, in upper surface, the positive charge gets created. In lower surface, there is a negative charge. Okay, so there are electrons in the lower side, and because of this, the in the upper side there is the that this plus, because there is a plus charge and there is a negative charge because of electrons, because electrons moving downward. Okay, and if this is an electron, so there are two forces which will act on electron. One is this this Fm, that magnetic field, because of magnetic field, right? Magnetic force, and above this, and in electron, this will be this electric field. Okay, Fe. So on electron, Fe and Fm will work. Okay, so we know that there is a random motion of electrons, free electrons in the conductor, right? And So because of magnetic field, all the free electrons will start moving downward along minus z direction, and due to that, in upper part there is a positive charge gets created, and in lower part negative charge gets created. Okay. So now at equilibrium, and we know the magnetic force on electron will be magnetic force Fm. We know that Fm is Q into V cross B. V is the velocity of electron. Okay, so this will be drift velocity of electron. Okay, drift velocity of electron. There will be random motion, and because of that, we know that electron moves with drift velocity, right? So V is the drift velocity, or we can write Vd. I'm writing just V. Okay, so it's a drift velocity, guys. Okay, so now from here, Fm is going to be Q into V, and direction of V, you can see direction V is minus y direction. Okay, V is minus y direction, because current is moving along positive y direction. Okay, so minus y cap and plus B into V. That the direction of V is along x axis, right? The magnetic field, so x cap. Okay, so this value is going to be QVB, and this is minus, we can take outside this side, and this is going to be y cross x, y cap cross x cap. Y cap cross x cap is going to be that Fm. We can write QVB and minus z cap, right? This is the one, right? Okay, so electronic charge is also minus E, right? This is going to be minus E. Minus is going to be plus. Okay, and y cross x is minus z. Okay, not inside. Okay, so this is the magnetic force, guys. Fm. Magnetic force. Magnetic force. Okay, and because of this, the electric field will get created between these two surfaces. Okay, the electric field will start working downward. Okay, electric field will get induced, and because of that, the potential will get induced. Okay, electric potential will get induced. Okay, and that is called Hall voltage, guys, along these two surfaces. Okay, so there will be potential difference which will be created. Okay, along the z direction. Because of that, along the z direction, along the direction perpendicular to y and magnetic field and this y direction, right? Perpendicular this and that voltage the voltage difference will create it, and that voltage difference is called Hall voltage, guys. Okay. Okay. So now we know at equilibrium, very simple, guys. So this is a conductor. There are 3 electrons. Okay, and this is the width, this is the length, this is thickness of the conductor. Okay, so what happens is because of magnetic field, electrons start moving downward, right? And they start collecting this on this surface, and because of that, positive charge gets created here, and positive charge gets created here, negative charge gets created here. That is, there is a electric field which gets induced along minus this direction. Okay, along minus that direction, and because of that, okay, just give me 1 second. There is camera not working. Just give me 1 second. Okay. Okay. Now it's started working. Okay. So okay. So because of that, there is a potential. Okay, that there would be induced potential which will get created, and the direction and that direction of this will be along that direction. That is called Hall voltage. Okay, voltage difference. Okay, Okay, so this is the theory for this Hall voltage. Okay, so at equilibrium, the force Fe, force on electron, is going to be force, electric force on the electron is going to be magnetic force on the electron. Fe equal to Fm at equilibrium I'm talking about. Okay, Fe upon Nm. Fe equal to mod Fe equal to mod Fm. Okay, Fe will, this is an electron, guys. Fe is working uh, this along the positive charge. Okay, up, and Fm is working down, towards down. Okay, working on in down. Okay, yes. So this Fe we know, right? Fe we know that mod of Fe is going to be QE. Okay, mod of Fe is QE, and mod of Fm is going to be QVB. QVB. V is the drift velocity. Okay, so QVB. So from here, uh, QBE or this the same thing, guys. Okay, Q and E is the same thing. So QBE. So here also this magnetic field is going to be QE. Q is the charge on electron. Okay, so same thing. So Q will get cancelled, and E is going to be equal to BV. B is the drift velocity. B is the magnetic field. Okay, this is one equation of electric field. Okay, now Hall voltage or induced voltage, the voltage get induced, right, and that will be along that direction, that is Hall voltage or induced voltage. So Hall voltage oblique induced voltage, induced Hall voltage oblique induced voltage, that is going to be VH. We know VH equal to ED. Okay, because here Hall voltage is along that direction, right? This is and this is positive layer, and this is negative layer. Okay, surface. So here the distance between positive layer and negative layer is D. Okay, so the electric field is along this direction, and electric field got created, right? And on this surface, and on this surface is a positive charge, this surface is a negative charge. Okay, the distance between these surfaces D, and E is the electric field, right? So induced voltage or Hall voltage is going to be E into D, this distance. Okay, so E into D, E into D, or we can write, or E value we have already found. So VH is going to be, the Hall voltage is going to be, VH is going to be, this is going to be ED, means BPD. Yeah, this is the important equation. VH equal to BVD. Okay, this is the Hall voltage. BVD or BVD. V is the drift velocity of electron, and V is the magnetic field, and D is the that thickness of the conductor. Okay, so BVD. So VH equal to BVD. This is also important formula you need to note down. And guys, we know here, we know I equal to, for conductor case, I equal to we know NEAVD, right? Or VD means so VD is drift velocity. So I'm writing VD as a V here. Okay, NEVD, right? So, and from here velocity VD is going to be, this is I upon NEA, right? And now we'll put this value in this equation. So VH is going to be, in that case VH is going to be BID upon NEA or NEA, right? NEA. So this is one VH equal to BID upon NEA. Okay, this is one formula for Hall voltage. And similarly, this A is, we know guys, A is that is A is W into D, that is area cross sectional area, right? Cross sectional area. This one here you can, this is W and this is D, area cross section. This is this one, okay, D into W. So area cross section. So in place of A, we can write WD. So VH is going to be BID upon NE, W into D. TD will get cancelled. So this is IB upon NEW. Or you can write, or you can this voltage or Hall voltage, or you can say like this, IB upon nu. Okay, for memorizing purpose, you can memorize like this also. Okay, IB upon nu, IB upon nu, or IB equal to NEW. W is the width of this width, right? This width. Okay, so this is VH equal to IB upon nu. Okay, so now and where W is the length of material along magnetic field, right? This is the length of material along magnetic field. And or there is one more formula, guys, that I'm going to write. VH equal to, this is also very important. VH equal to IB upon NET or IB upon net. Okay, like IB upon net exam, right? Net, you can say. Here T is the thickness of crystal. Okay, T is thickness of crystal. Okay, thickness of the crystal. In this case, the thickness is D. Okay, this one. Okay, thickness of crystal net. In this case, this is D. This is the thickness. Okay, so these formulas are very important formula. This one, E equal to BV and VH equal to BVD. This is important. VH equal to BVD and this VH equal to BID upon nu, or sorry, BID upon NEA, or VH equal to this one, important one, IB upon nu, or IB nu, or the last one is VH equal to IB upon net. All these formula you must note down and memorize it, guys. Okay, and solve questions using these formulas. Okay, then these formulas you can easily these formula are easily going to be memorized. Okay, and these formulas are going to be in your fingertips if you practice questions using these formulas. Okay, well, this is the one. This is the Hall voltage, guys. Now the Hall coefficient. Okay, Hall coefficient. Hall coefficient. Okay, Hall coefficient formula is RH, denoted by RH, and this is 1 upon N, guys. 1 upon N. N is the charge of electron, N is that number density. Okay, 1 upon N. Important one, guys. Second formula for Hall coefficient is RH equal to Ez upon Bx Jy. Okay, J, this is important formula. Okay, J is the current density along y direction. Current density along y direction. Okay, this is and Bx is magnetic field along x direction. Ez is electric field along z direction. Okay, so this is RH. Okay, RH equal to Ez upon Bx Bx Jy. These two formulas are very important. Okay, next. Next is this for semiconductor. What is the Hall coefficient? Okay, for semiconductor. Okay, for semiconductor, the Hall coefficient RH is very important formula you need to note down. That is P mu H square minus N mu E square, okay, upon E into P mu H plus N mu E whole square. Okay, so this is the very important formula. So RH equal to P mu H square minus N mu E square upon E into P mu H plus N mu E whole square. Okay, this is important one, where P equal to number of holes, okay, N equal to number of electrons, okay. N equal to number of electrons, okay, and mu H equal to mobility of holes, okay, mobility of holes, okay, and mu E is equal to mobility of electrons, okay, very important formula. So RH equal to P mu H square minus N mu E square upon E into P mu H plus N mu E whole square, okay. Okay, so if we talk about intrinsic semiconductor, okay, so if it is not just intrinsic semiconductor, okay, intrinsic if it is intrinsic semiconductor, okay, if it is intrinsic semiconductor, okay, in that case P is going to be equal to N, number of hole equal to going to be number of electron or equal to Ni square, okay. This is Ni. It is the case of intrinsic semiconductor. Ni, okay. So in that case, RH is going to be, so we'll put P equal to N, okay, in this equation, P equal to N. So this is going to be N mu H square minus N mu E square upon E into N mu H plus N mu E whole square, right? So RH is going to be, now we'll take N common, so this is going to be mu H plus mu E, mu H square minus mu E square equal to mu H plus mu E and mu H minus mu E, right? A square minus B square equal to A plus B, A minus B, right? This. And here what we will take N square common, so this is going to be N square E into, this is going to be mu H plus mu E whole square, right? So N will get cancelled, okay, and mu H plus mu E will get cancelled with this, and then RH is going to be, value of RH is going to be mu h minus mu h is mobility of holes. Okay, mu h minus mu e mu h minus mu e mu h minus mu e upon ne mu h plus mu e. This is in the case of semiconductor, intrinsic semiconductor. Okay, important one. So RH equal to this value. RH is going to be mu h minus mu e upon ne into mu h plus mu e. Mu h plus mu e. This is mu e, guys. Okay, mu h plus mu e. Okay, so where n is electron charge, charge on electron, n is the number of electron or hole. Okay, and mu is the mobility of electron, mu h is mobility of holes. Okay, so this is important. This is the Hall coefficient for intrinsic semiconductor. Okay, this one. This is okay. Here also you need to know, guys, mu h mobility of hole is very less than mu. So in that case, RH is going to be minus v, means the value of RH is going to be negative. Okay, because this mu is is greater than mu h. Mu is greater than mu h. Okay, next for n type and p type semiconductor. Okay, n type and p type semiconductor, will write a Hall coefficient. Okay, so for n type and p type, so this is going to be, guys, this one. RH for n type, here n is greater than p for n type. Okay, and value of n number of electrons are greater than p number of holes. Okay, so in that case, RH is going to be minus, we can minus n mu e square upon e into n mu e whole square. We have just in this we have neglected this p value, right? Because this this n is very greater than p, right? So we'll solve it. This is RH is going to be, if we solve it, minus 1 upon ne, minus 1 upon ne. This is mu e, right? So this is minus 1 upon Re. This is the Hall voltage. And similarly here, P is greater than N. Okay, value of P is greater than N. P is greater than N. Okay, P is greater than N. So in that case, number of holes are very greater than number of electrons, right? So in that case, RH is going to be P. We have neglected this part, right? This is very less. Okay, so P mu H whole square upon E into P mu H whole square. Okay, so this RH value is going to be this one plus P, right? This is so this is going to be first 1 upon N. Okay, my apology, 1 upon P. 1 upon P. Okay, P is the number of holes. P. 1 upon P. Okay, 1 upon P. So here R is equal to 1 upon P. So in that case, so this value is going to be positive. This is positive value, right? So these Hall coefficient for n type semiconductor is minus 1 upon Ne, and for p type it's 1 upon Pe. Okay, And also guys, this is important thing you need to know. This is this one, value of mu. Since we know v equal to mu e, vd equal to mu e, right? This we know, v equal to mu e. So from here, value of mu is going to be v upon e. V is the drift velocity, okay? Mu is going to be, value of mu is going to be, in terms of electric field, this is going to be v upon mu e. And also if you similarly, value of mu in terms of magnetic field is mu equal to 1 upon d, mu equal to 1 upon d, mu equal to 1 upon d. 1 upon d, okay? So this is also important formula, guys. So guys, well, I'm going to stop here. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science, okay? And also guys, please share my lecture details with your friends, so that they will also be able to watch my live lectures and will be benefited from it. Okay guys, thank you so much. Bye now.